Welcome to the Basics of Java Tutorial 1. In this tutorial, we would be discussing about Introduction to Object-Oriented Programming. The topics that are covered in this tutorial are Introduction to OOPS, that is Object-Oriented Programming, state and behavior of a class, encapsulation, inheritance, polymorphism, abstraction, and interfaces. If you are not familiar with classes, you can straight away jump to tutorial 10 of this series and get to know the basics of a class. Before that, you need to finish the installation of JDK and Eclipse on your machine, which are covered in tutorial 2. We will be discussing these concepts in greater depth in the tutorials 11 to 14. Introduction to OOPS. OOPS, also called Object-Oriented Programming, is a programming methodology used to make a complex software application. It's very difficult to manage using the other methodologies like structured programming. To develop and design a complex application in today's world, object-oriented programming is widely used, and it's very simple. And it is quite different as well. The basic elements of object-oriented programming are classes and objects. Class. In object-oriented programming, class represents an entity. An entity can be anything like animal, horse, factory, etc. In object-oriented world, we can simulate the surroundings using several classes. For example, if we want to simulate the cricket game, we can do it using several classes. These classes can be player, batsman, bowler, fielder, umpire, scorecard, gameplay, etc. All these key entities can make a complete cricket game simulator. These classes represent the state and behavior of entire game. By state, we mean the position of a particular entity. It can be the current score displayed on the scorecard, the current action taken by umpire, and the behavior of the entire game. This behavior can be a bowler is a fast bowler, etc. Similarly, in a bank application, we can have objects of several classes like account, customer, product, which map to the real-world entities and can behave in a similar way. Object. An object represents an instance of a class, and we can create several objects for a particular class. These objects hold the real state and can represent the behavior of a system. A class can be considered as a template, on top of which we can create an object of a class to hold the state of a system. State. An object of a particular class can have state and behavior which are derived from the class template. At a particular instance, the values set on the object variables tell us about the state of an object. For example, in a gaming environment, we can have resource loader, which loads all the resources involved in a game. While loading the resources, we can track each and every stage of the loading process using a variable called state, and we can restrict the variable to take the values start loading, loading images, loading sound, and end loading. At each and every stage, we can set the state variable of the resource loader object to track the progress of the game. Behavior. Apart from the variables involved in storing the state of an object can also behave in different way under different conditions. For example, we have an object of a class tall boy. We can track the state of the tall boy by setting the variable height. Now, if the tall boy can behave in different way as compared to a thin boy, tall boy can run faster. Running faster is the behavior of a tall boy. To track the behavior of a particular object, we have to use the methods. The classic behavior can be judged by the methods defined for a class. In this diagram, we have demonstrated how the state and behavior of an object of a class, resource loader, can be formulated. To track the state of a resource loader, we can have a variable known as background image, which stores the background image, background sound, and state to track the state of resource loader. The state variable can be an enumerated data type which can take the values start loading, loading images, loading sounds, loading configuration, and finally end loading. Apart from the class variables, we can have the methods start loading, which is a method to start the loading process, followed by load images, load sounds, load configuration, etc. Different methods can be used for different purpose, that is to track the behavior of a class. Inheritance. Inheritance means inheriting the features which were already defined for a particular entity in a real world. For example, human being inherits the features of an ape. The only thing is that we have different features like intelligence, we can reason, and logic. That is, most of the features of human being are similar to apes, but human beings behave in a different way as compared to ape. Most of our features are inherited from ape. The transfer and enhancement of features to generations can be considered as inheritance. So, we can say that features of class ape are inherited by class human being with certain enhancements. The enhancements can be intelligence, reason, and logic. And we can consider class human being as a subclass of class A. In object-oriented programming environment, we can use inheritance to reduce lot of time and avoid making the same thing again and again. Since the lot of functionalities could be written in the earlier classes and can be inherited by the new classes. Inheritance is the key feature of software reusability. We can use the existing classes defined by other users and can make further enhancements to the system by making use of inheritance. We can extend the features of predefined classes. In this picture, we can see that four-wheeler class is at the top of hierarchy. We have subclasses class car and class truck. These two classes inherit the properties of, that is, they inherit the features of four-wheeler class. But the two classes, class car and class truck, can have different features. In the same manner, the class car can also have subclasses like Mercedes car class and Ferrari class. The two subclasses Mercedes and Ferrari inherit the properties of car class, but the separate classes Mercedes and Ferrari can have different features altogether. Interfaces. Unlike other programming languages like C++, the multiple inheritance is not supported by Java. That means a single class cannot be a subclass of two or more than two superclasses. A class can be a subclass of only one superclass. This is where interfaces come into picture. In Java, multiple inheritance can be achieved using interfaces. The interfaces can be considered as pure abstract classes which do not implement anything on themselves, but the implementation part is left on the classes which implement these interfaces. Polymorphism. Polymorphism can be termed as an entity having. In this tutorial, we have learned that object-oriented programming makes it very easy to design and develop complex applications using the concepts of classes and objects. Each and every object of a particular class can have its own state and behavior. The state of an object can be identified by its variables and the behavior by methods. We have also learned the encapsulation, inheritance, polymorphism, abstraction, and interfaces concept. These concepts can be used to design applications which solve our day-to-day necessities in the software domain. In the next tutorial, we would be dealing with IDE, Integrated Development Environment, how to install Java and Eclipse IDE, and finally, a sample Hello World project in Eclipse. Thank you one and all.